On Friday, we discussed the first component of our mini module, how to build network apps. And today we're going to review some essentials for network security. You will have a brief assignment that will combine both components. So the one assignment will be worth 3 points. It's due by 11:59 p.m. tomorrow. And after class today, I will also post, before the day is out, a brief assessment on those two components. Because this is a mini module, you won't have as many questions, but it will be worth a significant amount of credit. So you do want to take the dash to the finish line seriously. So the good news is you log buku credit. The amount of material and the work you have to do to log that is a good bit less for a mini module than a full module. Okay, so great benefit, reduced effort. This is how we're going to finish the season. Does anyone have any questions about this last module or the information that's just been shared? Okay, allow me to update my my participants list very quickly. Good morning. So what I'd like to do first is to refresh just a bit about the coding segment that we covered on Friday. Remember that the diagram with the greater number of components represents the server side. That's because they have to set up a socket to listen. What we'll be demonstrating this morning is the use of Python 2.7 to connect to a well-known host, and then we'll do something in the realm of network security. So that's the goal today. We shared examples of Java coding, and then we also shared an example of some details that you'd find in C and C++. And then finally, we talked about a Python example. And that's exactly why we're working with the Python example. Now, you'll find that the example that has been shared from Black Hat Python, and the reference for that is in your study guide. There is a mistake in step number 3. So what I've done is taken the liberty of extracting some information from that example, and it's also included in this handy reference. So to complete this mini module assignment, you're going to watch the classroom demo that we're about to perform, and depending on whether or not you have Python already installed, you could follow along, and then you can perform the same tasks on your own system to satisfy the following criteria. Now, you may have a newer version of Python installed, but it's actually an older version of Python. Python universe is split into two main camps. There's a huge investment in legacy Python code that runs with Python version 2, and the latest version is 2.7. That includes the reference in Black Hat Python, the textbook that we're using for our demo. So in order to install Python 2.7, all you have to do is click this link. It'll download an MSI file into your downloads folder. The MSI file is not an executable, so you don't have to worry about trying to run it as administrator. You just double click it. Once it is installed, you have to modify the path in order to include some basic information. And If you already have Python 3 installed on your system, you're going to want to change the name of the executable. I'll show you that in just a moment. So in order to change the path, one way to do this is to go into your computing system properties and select Advanced System Settings. And from the Advanced tab, you'll see an option for environment variables. Does everybody see this? From the system variables section below, you're going to select path. And what you're going to want to do is edit this. And you'll add an entry. You can just double click and then go ahead and type this, right? So you can double click and add C:\\/ Python. And if it's the only Python installation you have on your system, you can leave it at Python. But I modified the installation so that it would install to Python 2.7. I wanted to differentiate between the older version and the new version. You can, if you don't have Python installed previously, simply use CPython and CPython \scripts, right? So because I have more than one version of Python on my system, I've used the actual version numbers. You could simplify it and put Python 2, and then if you have Python 3 already loaded, you could leave that Python 3. But are there any questions about what I've just explained? Now, if you already have Python installed on your system, one thing you'll want to do is differentiate between the two versions. So if you already had Python, a version of Python 3 loaded on your system, when you go into the directory for that, you'll find python.exe. And what you should do is change that to Python 3. Just add the number 3 to the end there. And then in the Python 2 directory, you want to change the exe from python.exe to Python 2. Now, if you have never installed Python before and you're loading this from scratch, again, you can accept the default Python directory without the numbers, and you can leave Python the way it is. Does anyone have any questions about what I've just explained as far as setting up Python? Any questions? Can someone unmute your mic to let me know you're still with us?
Still with you.
Okay. So let's take a look at how that'll work. If I open up my command prompt. And in this case, I'll navigate to Python 2.7 because I want to execute the proper Python command, right? I'm going to start by typing in Python 2. And I get a Python prompt. So that's one way, even if your path isn't established, you can make sure that you're loading the correct version of Python. You should see Python.2.7.10. Any questions about this? So if you get to this point, you don't see Python 2.7.10, you got to back up and assess. So once again, with your version, if you've never loaded Python, you might simply navigate to \Python and then just enter Python. You should see this. Now, in the assignment, we provide the statements for you. And all you're going to do is copy and paste these into the Python screen. So if I right click with my mouse When I see a 3-arrow prompt, that means that the command was successful, right? You'll notice the first thing that we do after we import the socket module in Python is that we establish two variables. We initialize two variables, one called target_host and target_port. And that's used later in a client connect command for target and port, right? Does everybody follow what I'm getting at? So let's do this quickly. So far, so good. Here's where we send some data to the host and we receive some data back. So I'm going to send this and I get a response back from the server about 36. That's a reference to the command that was sent. So that's a affirmation from the Google server. And then I want to get a response back from the web server at Google. That's going to store some information into the response variable, which has 4,096 characters for memory space. And now I'm going to print the response. Now, if I go ahead and scroll up, this is the portion. This is what you want to capture for the second criteria. So in your assignment, you receive 1 point for installing Python. And after Python is installed, the fact that you have a prompt that's working from the very beginning, when you load this and I see this on your screen, that's the criteria for the first submission. And then after you complete the final statement, you want to display all of this. That's what you submit for the second criteria. Any questions so far about our quick setup and use of a network socket using Python? It's really easy, really powerful. And of course, if you have any experience with web servers, with get and put commands, this will get you started. Okay. So the last part of our assignment concerns security. And we're going to spend the rest of our time explaining some essentials about network security that everyone should know before they finish this course. We've used NetSH before. And essentially, you may have recalled an activity where you did GRC shields up. Does everybody remember seeing a screen somewhat like this? Maybe not with all the blues, but
yes. Yep.
Okay. Now, if you've received a result from GRC shields up, it looks like a variety of ports have been unshielded by your firewall. This is a glaring example of how some network exposures are prevalent on your local area network. And essentially, this is a sure sign that additional investigation is warranted. Now, this may mean that you have exposures on your own client with open port and firewall rules, or there could be other activity that's present on your local area network, and depending on which firewall is active, these this output or results could be part of other connected clients if the firewall that's in place between you and GRC Shields Up is your Wi-Fi router. So this may be, put another way, this could be a result of what's happening on your local firewall with your local client, or it could be a summary of the exposures on your local area network with your Wi-Fi firewall. And so it's important to understand that distinction. You have more than one firewall. So you have a firewall on your local Windows and Mac system, but you also have a Wi-Fi router that has a firewall. And so this is called defense in depth. We'll talk about that more in a minute. In any case, if this is the output for a single client on your network, this could indicate the presence of a remote access Trojan, meaning your system's been owned, it's infected, and whoever has control of your system has established open ports that they can use to reestablish connections or reconnect to make sure their backdoor access remains intact. So anytime you see this again, it's just something you'd want to pay attention to. Now, the study guide that we have that touches on the essentials for equipment and network security, essentially the linchpin is investing in a managed switch. Did we not talk about managed versus unmanaged switches in our last session? Did we talk about this?
Yeah, we did.
So if you go to a vendor to buy a switch for your environment, make sure you get a managed switch that has an IP helper or DHCP helper capacity. This is going to pin whichever host connects to your network down to get the information it's supposed to have from your infrastructure and not from a hacker that's lurking on your network. It's also going to allow you to work a lot more efficiently by segmenting networks, and we'll talk about that more in a minute. So that's one of the important linchpins that, and it's not, again, this is a 48 port gigabit Ethernet switch that's only $320, so it's less than $10 per switch. So in any case, once you pin devices down to the proper DHCP server so that they are required to get their address from your DHCP, you can define the network criteria to include the DNS, right? So you can lock down what your clients are getting. They can't get a fake DNS server. They can't be redirected to an imposter DNS server or a malicious DNS server. So this is part of what we call defense in depth. And speaking of that, what I'd like to do is explain some basics here. So I'd like to kind of walk through this diagram section by section so that you get a chance to understand what it's about. Can everybody see the screen?
Yeah.
Yeah.
Okay. So if you think of a network, we have two characteristics of most networks: the local and the public, right? So, and this is true for most home environments too. So home networks work like this, business networks work like this. And essentially what you're looking at are typical symbols that are used to draw these pieces of equipment. But at a minimum, you want to have layers of network security components starting from the outside and working all the way in, right? And that's the way most people think. They think mostly in terms of the exposed internet, and it's actually a better practice to think about the inside first. So what you see here is the private internal network. Now, you know that private internal networks are certain address ranges, okay? 10.0, 10 dot something, 172.16 dot something, or 192.168 dot something. Those are private non-routable address ranges. And it's consistent that most network security experts will agree that for the average hacker, the use of a private non-routable internal address range makes it more difficult for the average hacker. Now, if you're talking about nation states, that changes the picture. But what's also important is that for different populations of devices, you should establish different networks. For example, if you have a mid-sized organization, you could have a 10.10.10 network for servers, a 10.10.20 network for staff. If we were using the university as an example, a 10.10.30 for faculty, a 10.10.40 for non-resident students, 50 for dorm students, 60 for guests, and so on. You want to have separate, smaller networks. And so, and we'll get back to this screen in a minute. I want to focus on this particular diagram. So even though people think about the big bad internet and they think, okay, I have a router, it's got a firewall, I'm good. It's actually a mistake to think in terms of network security by starting from the outside and just putting a door out there and then saying, okay, we're done. It's better to look on the inside. And I mentioned managed switches. So what you want to do is you want to have a managed switch that allows you to easily create separate networks and then create routes between those networks as needed, right? So you know that clients are going to be using server information, and you can control how and which clients access each other, provided they're in separate networks. But if they're not, if they're all in one big massive network, and there is no definition between those client populations, then you cannot exercise nearly as much control over which hosts can access which components. And a basic setup like this is incredibly troublesome. It's easy to set up, and most average hackers don't expect this. They expect everybody to have a huge open network where everything is just lumped together, and they can kind of have free reign here. Now, the other thing that I wanted to call out that's not so intuitive here is you see this reference to DNS. And in our last module, we mentioned this thing called split-split DNS, where we have internal DNS servers that help our clients find things out on the open internet to resolve common names for addresses. But then we also have another DNS out on the perimeter, out toward that's exposed to the internet. So we split the roles and the placement of DNS servers so that there's actually a pair of them. There's a second DNS server here that does the actual name resolution, and it relays that back to the inside. If this outer DNS server gets hacked, the only thing they're going to get for records are what someone inside the organization was browsing on the web, but they don't even know who. And then the other DNS server is what you use to advertise your zones. So if your organization has web servers and email servers and applications, right, then that DNS server that role has been removed from the inside. If that server is hacked, the only thing that a hacker gets out of that server is the information that everybody else has in the first place out on the internet. If you only have one DNS server and it shows where everybody is browsing, then you get intelligence on what the interests are for your users. If you only have one DNS server and it also includes the zone records, then you learn all of the sensitive network addresses for all of the named resources in that network environment. Put another way, if you put all your DNS eggs in one basket, you're a sitting duck. In combination with managed switches, a robust DHCP service that has IP helper, this split DNS is really important, because what you're doing is providing the DNS functions or resources, but you're splitting that up so that if one piece is lost, the rest of your organization inside is not exposed, where everybody can tell where your most important machines are. And what I'm going to do is stop at this stage and just ask, based on the information that I've presented, and by the way, this is the symbol for a managed switch, in case that's what Cisco uses, one of the symbols. That's a router symbol, that's a firewall symbol, and it's an oversimplification of a hand drawing. Does anyone have any questions based on the review the material presented so far? Anyone? Okay. Can someone unmute your mic and let me know that we're still together, because we had some heavy rain. I don't know if the network was disrupted. Are we still together?
Yep.
Yeah, I'm still there.
Okay. So this is just a rough hand drawing of a schematic that shows these different subnets, right? And the different infrastructure. WSUS is a Windows software update server, right? So you can actually push rapid updates inside. If you get a single copy of an update, this is stuff that we cover in other classes too. But being able to quickly and easily update Windows or your clients, whether they're host clients or their servers, that's really important. So whether you're dealing with clients or you're dealing with servers, bigger machines with lots of resources that everyone uses, you're going to want to make sure that you have this. Now, part of the managed switch scenario is having this layer 3 or core switch. That's the part, if you see a reference to layer 3 or core switch, that's a switch that includes some routing that allows quick setup of these segmented networks with essential routes in between, where you control the traffic between those host populations. Now, that's the end or edge of what we'd call the private internal non-routable network. And then out here, you have the open internet. And in between, you have this special zone called a demilitarized zone, or DMZ. Have you ever heard the term DMZ before? In military terms, a DMZ is a hot zone. It's closer to the threat. So a perimeter network is a network that's removed from but connected to the internal network. And it's explicitly and intentionally designed with additional security measures to harden anything that's out here that we would call public facing. If this is the public network, anything that's closest to that public network is said to be public facing. Does that make sense? So if you have a web server, an email server, right? You have your own DNS servers that advertise what you have and offer to the rest of the world, websites and email. See, those are public facing hosts. And because they're in this hot zone or perimeter network, they're considered to be hardened. They have extra security measures in place. They have a much tighter firewall configuration. They have additional access control lists, which is what ACL stands for, access control list. So a router with an access control list, if it sees network traffic coming to or from the public network and it's not in the access list, it just drops it, right? So this is kind of like a bulldozer in front of the firewall. And if this is configured properly, the firewall has lots of breathing room to do its job. If this is never configured properly, the firewall is overworked. So that's one thing to understand. You'll notice that this is where we also have VPN and the word proxy. This is a really important concept. If we browse, we have people in here that browse the internet. Those requests to browse should flow outbound through a proxy server. And it's this proxy server that actually interacts with bad guys out on the net, okay? VPN, of course, is how remote users connect to their internal network environment and resources. So people use a virtual private network connection to get to the important resources for their office environment securely. It's where the VPN, the proxy, the web server, the email server, the service router, and the advanced firewall or stateful firewall, right? This firewall, all these components are out here in the perimeter. There's a separate network called the perimeter network, and there could be more than one of them. So we could have a separate network for VPN connections, a separate network for proxy and firewall, a separate network for our hosts that face the public, or web server and email and DNS. So we could have separate subnets out here in the perimeter, but collectively, and spam filters. When you get email spam, a lot of that is filtered out when it hits the perimeter network, and there's a special piece of equipment that's really good at eating spam. Barracuda is one brand name that's actually pretty prominent and pretty popular, but there are many different kinds of spam filters. And so these extra layers of defense, when people are sending email in and it's malicious email, this spam filter can crunch and munch it before it ever gets inside, right? So these are the essentials that you need to have in the perimeter. A firewall that also branches out to different networks. The one that's public facing would be called a DMZ, right? A demilitarized zone. These are exposed. By the way, when there are extra security measures, we refer to those hosts with hardened security as a bastion host. Bastion meaning like castle. It's not the other word that sounds like it, in case you were wondering. Out here in the open, this is the wild, wild west. This is the open internet, and everything is terribly exposed. Public network addresses flow to and from the network wires and routes and between routers out here. And this is like, you don't ever want to have network stuff out here, ever, 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 ever. So this concludes a basic walkthrough. I did include a different diagram that goes into a little more detail with some extra notes like virtual LANs and other stuff. I'm just going to throw this in here for you to have a quick look. I was explaining some things in greater detail, but this is, you see the reference to virtual LANs. Those are virtual internal LANs, right? And this is a bad guy in the middle of this trying to figure out, okay, why can't I see any servers? Because I just hacked a PC. And that's because they're not in the same network. I don't know if that makes sense or not. An intrusion detection system is watching for suspicious activity. It's typical that a lot of malicious actors, when they get inside, they start doing certain things. And an IDS or intrusion detection system is actually listed here, right here. You can have an intrusion detection system inside. You can actually have an intrusion detection system out here. You want multiple layers of defense, and you want to structure your environment so that it's not simple to get around with if you're an uninvited guest. That's the main goal. Now, the perimeter components at a minimum include a stateful firewall, one or more screen subnets, and routers with ACLs. The internal components at a minimum include a layer 3 core switch for virtual LANs and managed networks, private subnets for different populations of users, and DNS in both areas, right? With intrusion detection inside. Remember that you don't want to start out on the perimeter. You want to start with the inside and build your defenses out. And if you don't have a private, non-routable internal network to begin with, shame on you. And I'm talking to everybody and anybody out there in the Caribbean who makes a nasty habit of just getting IP addresses from their service provider, and they just issue those IP addresses directly to hosts. They are sitting ducks. And it's not funny, and it's horrible that somebody would be using a public IP address. Just saying, okay? All right, and that's that other document. All right, any questions about what we've shared? So you do have an addendum inside the module 5, and the addendum includes more information about the security, right? So your addendum will have great information about how to and why are network security problems a challenge in the first place? Well, that's because the tech folks want things to work, and the security people want them to be locked down, and there's kind of a tug of war that goes on. I didn't know if you were aware of that, but there's other quick and important information, right? And there's mention of the pie hole, right? So more and more, there's many redirection when you click links or you respond on screen. The bad people are starting to embed these redirections in other links. And this is actually a really cool thing to do. So I just thought I'd mention that. We have just enough time to talk about our last part of the assignment, which I think is really, really cool. So we had, can everybody see the screen still?
Yeah.
Okay. Earlier in the semester, at the very beginning, we had you do some basic things in your home network environment, and it included a file that looked like this. Does everybody see this file?
Yeah.
Now
Yeah.
you'll notice that the website kind of mucks up the text file. It puts some strangeness in there. So what I would ask you to do is to download the file instead, right? So you should be able to download it, or yeah, you should be able to download this thing. And if you can't, yeah, let me know. I'll tell you what, I will email a copy of the Python 2.7 and the netstat netsh commands. I've added an extra netsh command option. Now, netsh was the one that showed you who your connected neighbors were. That's so powerful. So if you ever wondered, oh, why do I have this, right? That's where you can start to find out what's going on your network. So netsh, the thing we did in the very beginning in the first module, this is really helpful. But there are other options, and there's one in particular. When you see WLAN, that's a reference to Wi-Fi LAN. And if you use the netsh WLAN show profile command, it kind of sets the system up in a mode where it shows, okay, here are the Wi-Fi profiles you've been engaging, and it gives you a list. I'm going to show you that right now. So I'm going to go ahead. By the way, to get out of the Python prompt, you want to use Control-Z, okay? And I'm going to do a CLS to clear the screen. All right, everybody with me?
Yeah.
Okay, so essentially, you know what, I'm going to back up here. We'll start from I'll actually go into the temp folder. So if I issue the command netsh WLAN show profile, it shows all of the different wireless or Wi-Fi profiles. That's what the W stands, WLAN, right? I was connected to a Wi-Fi profile called JK Detmer, ERO, VINGN, right? Some of these are familiar. Bucks Wi-Fi. Oh, here's American Airlines Lounge. Now, if I follow that command with one more command, and I enter this, it's going to give me the key I had to type in to connect the shared secret, the password in the clear. Does everybody understand what I'm telling you right now? So if you highlight this and then use Control C and then use your right mouse button, it'll paste right in here. Does everybody see my screen?
Yeah.
Okay. Now what this is going to do is export that wireless profile and then put a text file in the temp folder with the key you use to connect to that Wi-Fi. And when you think about it, that's not a warm fuzzy thing. Somebody gets on your screen or they get in your system and they issue this command, they can see what you've connected to, and they can see what you had to enter to connect to it. So what it's doing now is it's exporting an XML text file into the temp folder. So if I go back into my temp folder, now I have a bunch of text folders that include all of those secrets. Now I did this previously and I extracted the information, right? And what you're looking for is the shared key. You're looking for the shared key component. And this is where it is right here. Okay, so it's not, there's the wireless password for my access to the Admiral's Lounge in Miami. So basically, you know how to connect now to the Admiral's Lounge in Miami if you're in the lounge or not. It's not a good thing, right? Now, what do I want you to do when you're doing this in your home? Do I want you to expose your secret key and submit it to your instructor? Yes, for additional credit, I want you to send your secret Wi-Fi key to me, your instructor, who will promise to keep it a secret. I will never share with anyone. Is that what you want to do? No.
Not without any legal binding.
Yeah, you don't want to do that. What you can do is I want you to highlight it like this. Okay, everybody see what I'm doing?
Yeah.
In your notepad, I want you to find one that has a shared key that displays it plainly. And I want you to use the Alt print screen to capture this. And then in Paint, for your third criteria to capture full credit, I want you to take the little pencil here and make the line really thick. And I want you to do this. Okay. And then I want you to save it as number 3. So you do a save as 3 for your submission in 5.1. So 5.1 tKentop number 3, right? Everybody get what I'm saying?
Yeah.
I want you to see how easy and how dangerous this is, but then I don't want you to expose yourself, just in case my own profile gets hacked on Blackboard. I'm just saying. You know, because I have other courses I work with, and last semester around this time, in late April, we had students in the system security class, and we had some hosts on a network in Charleston, South Carolina. And you will actually be using these hosts this next semester. And we found out that one of the machines looked like this. We started doing some quick work, And before we went very long with NetSH and NetStat, we found out with a backtrace of the IP address, it was Moscow, Russia, that was inside that machine, live in the system security course. So it doesn't get any cooler than this. I know that you've suffered long to learn all of the specifics about networking, but now that you know the ins and outs of networking, and you know what to do to set up important resources, named resources, so that your coding works well when you're creating network applications, you'll also know the finer points to keep everyone safe. You'll close the ports after you're finished using them. You'll shut the door, and you'll insist on part of the support for your application to be robust requirements for DNS, so that people in the local network will do what they're supposed to define your named resources for the code you're writing. Yeah, you're in the driver's seat here. You can also write your code so that if there's stupid things that happen with your code, it can flash an error at your user so that they get a clue that they need to close their own door. I'm just saying, right? Now that you know how, you can use it for good. Okay. So that's the last component of what we need you to do for your last assignment in this course. And then, as I said, before the day is out, a short assignment for coding network apps and securing networks, right? Two important skill sets, lots of benefit, not a lot of effort. Take the time to get it right. That's how we want to finish out the course. Okay. Are there any questions, comments, observations, concerns based on the material that's been presented today? If I don't see you before finals week, I do want to share with you that I'll be posting when the final exam will be made available. You don't have to finish it at the scheduled time. You can complete the final exam before 11:59 p.m., not this Saturday, but the following Saturday at the end of finals week. You do have a chance to resubmit any assignments or solutions if you find out that you missed something. And I would encourage everyone to finish your retakes for all the assessments before you take your final exam. It's a great way to study for your final exam. Any questions before we stop today?
We still have a fifth assessment for.
Yes, you will
Okay.
have a fifth assessment. It's right here. You're going to see it right below your assignment. That will be active a little later today. You won't have as many questions, but it will be worth as much. Because if it's one thing I want you to get out of this course really well, how to set up a quick, fast, and easy network application, and how to keep things safe, right?
Mhm.
Yeah, so that's what's going to be in this assessment. Glad you asked. I know that the network connections people are in and out of the session. Any other questions before we clear? Okay, let us know if you run into any snags. We will remain available as needed.